Good morning. This is Prasanta samal. Welcome you to the academic YouTube channel of Prasanta Institute of Technology. In today's class, I will discuss the chapter of alternator in the subject of energy conversion. In previous video, I had already discussed all about the salient pole type alternator. In today's class, I will discuss all about the non-salient pole type alternator. So what is a non-salient pole type alternator? Non-salient pole type alternator means smooth cylindrical pole type alternator. In this type of alternator, in this type of rotor, the rotor is made up of smooth solid for steel radial cylinder having number of slots along the outer periphery. So this figure shows a 4-pole non-salient pole alternator. In this case, you will see that there are 4 poles, north, south, and these are the slots. These are the slots along which the field windings are embedded. And in this case, the field windings are embedded in series with the slip rings. These are the 2 slip rings. These are the 2 slip rings. And in this case, the field windings are embedded in these slots and they are connected in series with the slip rings, through which DC supply is given. So generally this type of non-salient pole type alternator is used in thermal power plant where the speed is almost 1500 to 3000 RPM, and generally this non-salient pole type alternator has small diameter and large axial length. So this is the non-salient pole type alternator. So next, I will discuss all about the principle of operation of alternator. Principle of operation. So the principle of operation of alternator is Faraday's laws of electromagnetic induction. As already you know that alternator has 2 inputs. One is the mechanical energy which is given to the prime mover, and second is the DC supply which is given to the rotor field windings. So in this case, in alternator, the mechanical energy and DC supply cannot be given simultaneously. It cannot be given simultaneously. So first we have to the rotor field windings. But rotor field windings are energized. Rotor field windings are energized by DC supply so that the adjacent pole become opposite. If there is a 2-pole rotor, then north and south pole will be created, and if there will be a 4-pole rotor, then north, south. In this way, 4 pole will be created. It means that when a DC supply is given, the adjacent pole become opposite. Thereafter, mechanical energy is given by the prime mover to the shaft of the rotors. So when mechanical energy is given to the shaft of the rotor, then what happens? The field windings will be moving, the rotor field windings will be moving, and in this way, the starter conductor or the armature is caught by the magnetic flux of rotor poles, and hence an EMF will be induced in the starter winding. And this EMF is alternating in nature. Since if north pole passes across one conductor, then a positive voltage will be induced, and thereafter south pole passes across the same conductor, then a negative voltage is induced. So in this way, a continuously alternating EMF will be induced in the alternator. This is all about the principle of operation of alternator, and next we will discuss about the frequency of alternating EMF. Then we will discuss the frequency of induced EMF. So in this case, what is the value of frequency of induced EMF? The induced EMF which is generated in the alternator, what is its frequency? So let us explain this. Let n is the rotor speed in RPM, let n is the rotor speed in revolution per minute, p is the number of rotor poles, and f is the frequency of EMF in hertz. If north pole passes across one starter conductor, if north pole passes across starter conductor, then a positive voltage will be induced, and thereafter if south pole passes across the same conductor, a negative voltage will be induced. So in this case you will see that one complete cycle of EMF is generated when one pole pair passes across the armature conductors. It means that the number of cycles per revolution, is equal to number of pair of poles, and that is equal to P by 2. If P is the number of poles, the number of pair pole will be equal to P by 2, and N is the rotor speed in RPM, that is the revolution per minute. If we convert it into revolution per second, then what happens? Revolution per second is equal to N by 60. So revolution per minute is N, whereas the revolution per second is equal to N by 60. Now you see that if we multiply these two equations, that is the cycles per revolution into revolution per second, then we will get the cycles per second. The cycles per second and is equal to P by 2 into N by 60, and that is equal to P by 2 into N by 60, and that is equal to NP by 1. And number of cycles per second is nothing but the frequency of induced EMF. So you can write cycle by second is frequency F, which is equal to NP by 120. So this is the relation of frequency of induced EMF. So it is all about the frequency of induced EMF. Thanks.